Hello everyone. In this tutorial video, I'd like to introduce you to parametric equations, or expressions of x and y in terms of a third variable rather than each other. For example, if we were asked to sketch this parametric equation, we would plug in different x and y values to get a guess of what the graph is. Or more specifically, plug in different t values to see what x and y values these t's produce, and then make the graph from that. Once we do this, we get a parabola, but it is horizontally shaped rather than the usual vertical one. And we also see that the t values we plugged in give us a specific direction of motion along this curve, which we indicate with black arrows on the curve. Just like we can limit x values in terms of specific values, we can do the same thing with t values. So if we want to confine t between -1 and 1, the graph would look like this, although it would still have the same direction of motion. The problem with this method, however, is that we are only making assumptions/guesses about what the graph will look like based off plugging in arbitrary numbers. We do not have definite evidence that the graph will be valid for all values. So what we do to fix this is to use a method known as eliminating the parameter, where we solve either x or y for t. Usually, the smarter move would be to use the one that is more simpler to solve for t, and plug in this value of t for both equations. For example, if we want to eliminate the parameter of the graph we just sketched, we would see that y is easier to solve in terms of t. We do this and we get t equals 1/2 y plus 1. So now we plug this in for the x, and we get a graph for a parabola that opens right. Although we guessed it was this shape, based off arbitrary t values, we now have a definite function that we know will give us all these values, which we did not have before. With that out of the way, if we were asked to sketch this set of parametric equations, and told to restrict t between 0 and 2 pi, we would solve for the x component, although that is simply an arbitrary choice because the y component is just as easy in this case. We get t equals inverse cosine of x over 5, so now we plug this in for the y. We see, unfortunately, we get a very messy answer that does not graph out into anything we know, so we will have to consider alternative, more creative ways. If we remember the formula cosine squared plus sine squared equals 1, we would first divide x and y by their constants so that we only have cosine and sine. So now we have 1 equals x over 5 squared plus y over 2 squared. And once we square everything out, we get x squared over 25 plus y squared over 4. In conclusion, we have definite evidence that we have the graph of an ellipse, because we have a longer radius for the x or y versus the other part. Interestingly enough, if we did not limit ourselves to 2 pi maximum, we would still get the same exact graph, because of the fact an ellipse will repeat itself after 2 pi, or after you have rotated around the full circumference. The only caveat we have to keep in mind is because we did not restrict t to an amount of finite values, we have an infinite amount of t's on each point instead of simply 1, but it is the same graph otherwise. If we are given this set of parametric equations, we do the Pythagorean identity again because we have trig functions for both x and y. We see because x is already something squared, we do not have to square it again, but we do have to square the y. So when we rearrange the identity, we get x equals 1 minus y squared over 4. We next get limits of the x and y values. So because sine is between -1 and 1, it follows sine squared is between 0 and 1, as sine squared is always positive. So x must be between 0 and 1. And similarly, because we know cosine is between -1 and 1, we multiply everything by 2, and we get our limits for y. So now we sketch this graph, and see, it looks somewhat like half a football. Interestingly enough, the motion of this graph is not in one direction throughout the whole thing, but is more chaotic, because of the fact as trig functions x and y will give you different values for different t inputs, sometimes negative and sometimes positive. So we take all this into account once we sketch the graph. Now that we have figured out how to sketch parametric equations, we can discuss the derivatives of parametric equations next, and how they are different from normal derivatives, or even the chain rule, because of the fact we have two separate functions at the same time related to a third variable. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.